pioneers of humanity launching the next generation of robotic explorers to the Red Planet.
Perseverance will push forward the boundaries of a decades-long investigation into whether Mars has ever hosted life in its 4.5 billion year history. On board is a suite of scientific instruments designed to look for signs of ancient life. It will also start to investigate how humans might live there, and for the first time ever, we'll see if we can fly a helicopter on another world. Its predecessors investigated whether Mars ever had habitable conditions, particularly looking for evidence of liquid water. Together with observations from Mars orbiters, they gathered evidence that Mars once had large oceans, rivers, and lakes. They even found hints that water still flows on Mars today, although some features that were originally interpreted as streaks of flowing water might actually be just sand. We now know that Mars has the ingredients for life, and it may have been much warmer in the past. Perseverance will be the first rover to explicitly look for signs of life itself. The chances of finding current life on Mars are pretty slim, but in the distant past, it's not so far-fetched, and finding it would be a huge deal. Right now, Earth is the only place we know of where life has ever existed. If we were to find out that life existed on our nearest neighbour, it would tell us that our home is not unique, and maybe life elsewhere in the universe is actually quite common. Perseverance will reach Mars in February 2021. The launch was timed so that the positions of Earth and Mars would make the journey as quick as possible, giving a flight time of about 7 months. The landing site is Jezero Crater, which is believed to be the best candidate for finding life on Mars. Water and sediments collected in this former lake bed, and it's here that scientists hope to find ancient organic molecules and signs of microbial life. To do that, the rover is carrying a set of high-tech gadgets that would put even James Bond's Aston Martin to shame. There's a nuclear generator, a computer, an identical backup computer, 6-wheel drive, a triple-jointed robotic arm, a drill, a weather station, and microphones, so we'll get to hear Mars for the first time. One key bit of kit to look for signs of life is called Sherlock. That's a contrived acronym with lots of jargony words, but what it does is shine a laser at the rocks and measures the spectrum they reflect to determine their chemical composition. It even has a sidekick, a camera called Watson. But Perseverance isn't just taking pictures. The rover will collect bits of Martian rock in tubes to be collected by a future mission. Hopefully, we could have those tubes back on Earth to study in 2031, which would get scientists really excited. To keep up to date with everything that's going on in space exploration, subscribe to New Scientist. We've got a 20% discount for our YouTube viewers. Just enter the code SAM20 and click the link below. And if you want to have a closer look at the amazing astrophotography pictures you can see behind me, do a search for the Astronomy Photographer of the Year here at the National Maritime Museum in London. On top of the hunt for life, Perseverance is going to attempt something extraordinary. Mars is about to get its first helicopter. Ingenuity is a Wright brothers moment on another planet, according to the lead engineer Mimi Ong. If all goes to plan, just 118 years after the Wright Flyer took off in North Carolina, a 1.8 kilogram helicopter will take off on Mars. To complete its mission, all it has to do is get off the ground. Later missions could include bigger helicopters or maybe even planes that can fly further around the planet. Because Mars's atmosphere is so thin, that mission isn't so easy. Its super light carbon fiber blades will have to spin at 2,400 revolutions per minute. That's 7 times faster than a typical helicopter on Earth.
2,400, 2,600.
Another exciting experiment on board Perseverance will see if it's possible to produce small amounts of oxygen on Mars. That's going to be absolutely crucial when we eventually send humans there, because they'll not only need oxygen to breathe, but they'll need it to burn fuel and get a rocket back to Earth. Mars has only trace amounts of free oxygen in its atmosphere, but it has quite a bit of oxygen bonded to carbon atoms in the form of carbon dioxide. This experiment, called MOXIE, will test the technology for making oxygen from carbon dioxide on Mars. MOXIE takes in small amounts of carbon dioxide from the Martian air, pressurizes it, and heats it to 800 degrees. A combination of heat and electricity rip oxygen atoms away from the carbon dioxide, leaving you with carbon monoxide and oxygen. MOXIE is expected to produce 10 grams of oxygen an hour. That's barely enough to breathe for 15 minutes. But MOXIE is just a test. MOXIE is about the size of a car battery. For a human mission to Mars, we would need something about 100 times bigger. And if we were going to send a rocket home, we would need 30 to 45 metric tons of oxygen, more if we're ever going to settle there. Mars isn't exactly the most hospitable place to settle down, but some people, including SpaceX boss Elon Musk, are really keen on the idea.
Do you want the future where we become a spacefaring civilization and are in many worlds and are out there among the stars, or one where we are forever confined to Earth? And I say it is the first.
Perseverance will take some of the first steps to see if that's possible. So we're going to learn a lot from this mission. We're going to see if it's possible to fly a helicopter on another planet, we'll prepare for future human exploration, and just maybe we'll find signs of ancient life on another planet.
I believe someday we will send humans to Mars. I'm pretty sure that humanity, won't give up this dream. But before that, we will have a humanoid robot. So that's why maybe having astronauts in orbit and controlling robots on different surface locations could be also interesting.
How is Justin doing? Is he ready to go to work?
He's been waiting for you.
This is our SolX Proving Ground, we call it. It's a simulated Martian environment, and it's based for the scenario of the first humans arriving on Mars. In this scenario, we assume that astronauts on board the ISS are orbiting around Mars and commanding the robots from there.
We are the crew on orbit around Mars, and we send a rover down there as the first scout to see how the conditions are like, whether it's safe, what the atmospheric parameters are. And so we command that rover, but the difference to how rovers were commanded in the past is that this rover actually knows to navigate by himself. So I don't have to tell him every millimeter to move in which direction or what to do exactly, but I just give him high-level commands like check out this solar panel or pick up this rock.
Of course, this is a dream of sending humans, but it's costly, it's dangerous, dull, dirty. These are the jobs the robots will have the first application in, for sure.
I'm here at Woodside's head office in Perth, Western Australia, to meet one of the most advanced humanoid robots in the world. Her name is Valkyrie, and she's part of a fascinating collaboration between one of the world's biggest energy companies and NASA. What exactly is Valkyrie doing here in Perth?
We are looking at how we can take away high-risk tasks like high-voltage switching, which currently humans do, to either automate them or be able to use a tool that can exercise them. Everything on the assets have been designed for humans, and so when you scale up to trying to get a tool that can do multiple of these tasks, it may look like a humanoid robot with the dexterous capability of a human. That's what it's doing here, and that's the vision for the future.
I've effectively kind of stepped into Valkyrie's body. If I put my right hand out, her right hand goes out. And if I'm moving my head now, her head is moving. Just had the chance to control Valkyrie. It was such a bizarre experience, being able to control her arms and her head. Valkyrie tests the kind of capacity that a robot like her needs in order to be able to undertake some of the most dangerous tasks that are currently done by people, and one day perhaps to be able to participate in Artemis missions, maybe a trip to Mars.
CADRE is a technology that's going to the moon to demonstrate how multiple robots can work together as a team, cooperatively and autonomously at the same time.
We're going to have 3 robots on the base station. They each have what we call multi-agent autonomy, meaning another layer of autonomy that allows them to work together as a team. So we no longer have to micromanage what each one of the robots is doing. We don't tell them, this is what you should do, this is what the other robot should do, but really we just give the team an overall objective, like explore this area. And then they elect the team leader amongst themselves, and then they plan how to divide that problem up, execute it, and send us back the data.
This is one of the 3 rovers that we're going to send to the moon that's made it to what's called a deployer. And the deployer helps the rover to detach from the lander and get onto the surface of the moon. And the rovers have these solar panels which are actually folded right now in the stowed condition. Once the lander lands on the moon and the rover egresses from the lander, they'll open up their solar panels to start charging. They also have a battery here for the initial part of the mission before they open up the solar arrays. So once it's on the surface of the moon, we have these wheels that would help it drive on the surface. We designed the wheels such that the dust doesn't keep up and deposit on the solar panels or radiators when it's driving. There's a pair of stereo cameras on this side and a pair of stereo cameras on the other side. So if the rover doesn't get a good image from one set of cameras because, say, the sunlight is in its eyes, if you will, it can drive using the other side of cameras backward. Each of these rovers has what we call a ground penetrating radar, which will help it map the subsurface of the moon. So it has these white cylinders, that's the antenna that it uses to do those measurements on the surface of the moon.
When you just bring a single ground penetrating radar, you end up with this 2D image of the subsurface. But once you have the ability to deploy multiple ground penetrating radars into an environment, you can actually do 3D imaging. You gain the ability to be a lot more accurate with what you're able to see because they're measuring not only their own radar signals that they're sending into the ground, but also those of others. And you're able to kind of correlate that and get a better science data product out of that. On the CADRE system, if we, for example, wanted to measure more deeply into the subsurface, the robots would basically figure out we need to go and spread out and take measurements further apart. Or if they want to measure more shallow, they group together more closely. So you have quite a bit more flexibility in the system to kind of almost tune how you want that distributed instrument to work. And then you could also think of a variety of other uses for such a multi-agent system for exploration purposes. For example, where maybe you want to have a communication chain to reach new areas that you couldn't with a single robot.
Getting to extreme terrain, places that you wouldn't normally be able to send humans to, like lava caves or ice caves. But also in combination with human astronauts, rovers can be used for sample return or surface mapping and exploration and things like that. Instead of asking ourselves, what can this rover do? We will be asking, how many rovers do we send and what can they do together? So for example, if one of the rovers were to go into an extreme terrain and not survive, the other rovers will still be able to return the data because they've all been working together as a team. So it builds up resiliency of the experiment. Fundamentally, this will change how we explore the moon or any planetary body. Once we show this successfully working on the moon, we could potentially send this same technology to anywhere, right? To Mars, to ocean worlds, to other kind of terrain. But also the autonomy software can be ported to not just rovers, but it could be drones. It could be a combination of rovers and drones. So the possibilities are endless.
Folks are maybe now going to be inspired not to just think about, okay, well, maybe I'm going to send one robot there and what can I do with it? But what could I do with more robots, right? Like, what does that enable me to do for the science that I care about, for the exploration that I care about? Autonomy can really help us explore further into our solar system.
Traditionally, rovers are operated from the Earth. With the Lunar Gateway being put in place around the Moon, there's the possibility of controlling them directly with much smaller time delay. And this opens up for new possibilities for things that you simply cannot do or is much more difficult to do from the Earth.
For our robots, we really focus on teleoperation. But we go a step further. We use haptic controllers to move our robots, especially move robotic arms. So if you move our haptic device and the robot touches an obstacle, you indeed feel the touch. And this allows the operator to do more fine-grained tasks that is not possible without haptic feedback.
Astronaut time is extremely valuable, so you can send a rover to the surface, you can let the ground team do all their planning, let them do all the longer traverses, and you get the astronaut involved when it's necessary for maybe the more complex task or the things where he really direct teleoperation, direct control of the robot is more helpful.
This is one of the first times we put out the robot in a really harsh environment here on Mount Etna. So it's moon-like, we have a complex scenario with the operations center in the background, the astronaut with time delay in the control center, and indeed a task that was not known to the scientists and to the astronaut beforehand. We really tried to get as close as possible to real scenarios with surprises.
It's certainly less dangerous to send a rover to the surface than to send an astronaut. It's also cheaper. It's also possible to not take up so much of their time.
If we master this, we are really confident that these technologies can be developed further to make it space grade.
This is a physical model of our master plan for a moon base for the European Space Agency. ESA and NASA, they are now working on projects such as Gateway and Artemis. We obviously are going back to the moon. But once we're there, we're probably going to want to stay there. And we're going to want to stay there and grow a community. What it really is a master plan for a lunar base set in the future.
More people on the moon in a sustainable way. This is a good picture to have in mind. What we are preparing is how to make those possibles concrete.
Even in such remote and harsh environments, it is very fruitful for science to discover important data about our planet Earth. So we will fly out there and we will set up a small house on the moon, initially maybe for 4 astronauts. And these astronaut researchers will learn a lot, perform a lot of experiments. And we will evaluate this data, and I'm pretty sure we will decide, oh, we need more researchers on the surface of the moon because what they are achieving as science output is absolutely relevant for our planet Earth. We have a common history together, so we can use the moon to look back into the past of planet Earth. And then by finding water on the moon, we can actually also answer the question, how did life start on planet Earth? And that's super fascinating. So I spent 6 months on the International Space Station, and these environments are actually not made for humans. We need to bring everything to make human life possible.
It's about understanding what we don't know and what we know very little of, and what we need to do in order to know more and in order to solve any problems that might arise from what we will discover. One very good example is the radiation.
Earth is magnetically charged, which creates a protection shield against radiation. On the moon, we do not have that. So that radiation is hitting our astronauts constantly. So what we need to do, we need to protect them from that. How do we do that? Well, you need mass around you. In this design and previous designs that we've done, we're looking at creating these shell structures made out of local material, which is regolith. And the first thing you might notice is all these gray mounds that you see on the model, made out of these little tetrapods. And what they do, they are made out of lunar dust, and we creating these shell structures bit by bit, part by part, they're actually thrown on top of each other until they create these kind of fully 3D shell structures. And what they are there to protect our astronauts, protect them from radiation. The moon is a terrible place to be at, right? It has no atmosphere, has 1/6 of gravity, and it's full of regolith, which is, because there was no erosion on the moon, is really static, electrically charged, and it's very sharp, right? So it's really abrasive on everything. So for us, the first thing is really trying to create spaces that are safe for these astronauts to live. So we want to make sure that our habitats don't really touch, or only lightly touch the lunar surface.
We can learn from the Apollo era, and there we see photos when the astronauts, they came back from a spacewalk and are now on the inside of their spacecraft, and we see lots of grey, dark traces in their faces and across their spacesuits as well. They brought the contamination from the outside to the inside, and the moon sand, it's highly abrasive, so we don't want to inhale it. It's a health risk. It's also a risk for the entire technical devices and appliances that we bring to the moon.
So for that reason, we designed these inflatable modules, really, that are only touching on both ends the lunar surface. They're like big bridges. It actually works like a beam, like an inflatable beam structure. So the structure is really light. It only needs the inflatable, the air, of course, and some cables and a very small compression element on the top. So it's all about kind of having the minimal amount of material to create the larger amount of volume. For us, it's not about astronauts being able to survive, but also to thrive. One of the things that we don't know, what this kind of lunar economy will look like, right? Is there going to be universities there? Is it going to be bioengineering firms there? Is there going to be manufacturing there? Will tourism be there? And how big will tourism be, or how small? We don't know yet. So in our plan, what we've done, we kind of made a master plan that allows for all of these changes. In the model, we have 4 of these pods. These are inflatable pods. We've designed them very modular. When the base grows, we can actually change the functionality. This one here is a living space with 4 astronauts living. I've just added a lab to it and a little lounge. But we can change it again if we want to. So we're starting to look at what kind of spaces do we need to create if we have a larger community there. You know, what if we have 144 astronauts there? They'll need more than just the facilities that they have now in space.
You cannot make a short-term plan if you don't have a long-term objective. And that's what we are doing with concept studies technologies. We are trying to prepare the ground for the objective that we have in long term, that they will inform the capabilities that we need at the moment. Thinking about this long-term vision, the right time to start developing those capabilities is really now.
Is it running before we can walk? I don't think so. These things take a long time to plan, and the way we're looking at it is not really science fiction. It's really using existing technology, existing work that's being developed, and then seeing how we can incorporate that in an overall vision.
ESA has already 3 flights to the moon, and we are currently 6 European astronauts who can be selected for these 3 missions. I'm one of these candidates, and I'm absolutely looking forward to fulfill my 3rd big dream, to explore the surface of the moon. I would like to contribute to the exploration of the moon, to make sure that we also deliver the science.
I'm here at the International Conference on Robotics and Automation, the world's largest robotics conference, which this year has come to London. 4-legged robots from Boston Dynamics, we've got Unitree's robot, we've got humanoid robots, assistance robots, every sort of robot you can imagine. You might be wondering what these robots are doing right now. It looks like they're just playing a game of chess, but this robot on my left is being controlled by a human in a suit over there, and this robot on my right is being controlled by a human over there. They both have feedback gloves, they have VR headsets, and they're seeing everything that the robot sees. Now, specifically today, we're looking at avatars, robot avatars to be precise. They can play chess, but they can do much more. They can perform maintenance, rescue operations, and do anything that a human can do with its hands and eyes.
So we built a robot that is easy to control for a human, and the human feels as if the robot was their own body. There's many applications, for example, in healthcare, remote assistance, there's also disaster response in dangerous situations, also connecting people closer together.
As I put on the VR headset, I began to see what a future of human-controlled robots might look like. I knew the robot body I was inhabiting wasn't my own, but I couldn't help but feel that part of me, as I looked back on my human body, was the robot.
Wow. Nice to be back in my own body.
How do you feel?
It's amazing how responsive it is. Like I really, obviously I had a bit of trouble with the chess set, but I was able to sort of pick things up and move things, and yeah, it felt like I could do almost anything that I could as a human.
It's still strange, even for me, especially if I see myself in the operator station through the avatar. The reason it's exciting for us is because we can learn from humans that control the robotic system, and then the robot gets smarter and can do things on its own. For example, picking up a drill using a device. These are things that humans do intuitively, but it's very hard for robots to match. And if you can just imitate what humans do, but with the limitation of the robot, then that brings us forward in robotics.
One way that robots are being used currently in the real world is at places like the UK Atomic Energy Authority. They are the government agency that manages power plants across the UK in high radiation environments. They have a robot that uses robotic grippers like this to perform maintenance and perform tasks inside the reactor where humans can't go. Using this setup behind me, which is a bit like a flight simulator, they are training new operators for this robotic arm.
The exciting thing about avatar control these days is that now that VR technology has come to where it is, you get really highest resolution and fidelity in the VR headset, and the robots are at a level now where they can be precision control using regular Wi-Fi. You can now start deploying robots and androids into applications where you don't want the human to be present.
So Eve is a humanoid robot, so it matches the embodiment of a human, has 2 arms.
I am waving to myself in robot form. Obviously, I'm not actually in the robot, but just seeing myself and having this robot sense of self is a very strange feeling. I am in the robot, part human. I'll give the camera a little wave there.
Currently, the commercial application is physical security in the US. And in that application, the robot does autonomous patrols. That includes opening doors and riding elevators. And then when needed, it can hand over control to a human. The human can assess the situation through the eyes of the robot, solve the issue, and then move on. In 5 years, I expect when you go to Heathrow Airport, you'll see androids doing many tasks. In 10 years, I think it would also be in elder care, so elderly people living at home will have robots helping them at home, or androids. And then the step beyond that, which is the robots in every consumer's home, I don't want to put a date to that, but that will come later, I think.
Behind Behind me is Amica, a humanoid robot designed to look as much like and speak as much like a human as possible. It might be a while before we see robots like Amica in the home, but as we've seen today, humanoid robots and robotic avatars are getting closer and closer to real-world use. Not to mention robotic dogs, flying robots, underwater robots, robots used in nuclear maintenance, used in search and rescue, used for all sorts of tasks. It'll be a while before we see something like Amica in the home, but it might not be too long before we see something a little less lifelike, helping you out with everyday tasks.
The exciting thing about avatar control these days is that now that VR technology has come to where it is, you get really, really high resolution and fidelity in the VR headset. And the robots are at a level now where they can be precision control using regular Wi-Fi. You can now start deploying robots and androids into applications where you don't want the human to be present.
So Eve is a humanoid robot, so it matches the embodiment of a human, has 2 arms. Today we're showing the virtual reality teleoperation. So I'm gonna, basically you can wear the headset, get the controllers, control the arms, control the grippers, and drive around a bit the show floor.
As I put on the VR headset, I began to see what a future of human-controlled robots might look like. I knew the robot body I was inhabiting wasn't my own, but I couldn't help but feel that part of me, as I looked back on my human body, was the robot. It was a strange, disconcerting feeling.
If I look presumably to my right, I might see myself. I can see my hands out there.
Exactly, you can see yourself.
So I'm now in the robot body.
Exactly.
I am waving to myself in robot form. Obviously, I'm not actually in the robot, but just seeing myself and having this robot sense of self is a very strange feeling. I can see my own body over there, and in some way, I'm not connected to it. I am in the robot, part human. I'll give the camera a little wave there.
Currently, the commercial application is physical security in the US. And in that application, the robot does autonomous patrols. That includes opening doors and riding elevators. And then when needed, it can hand over control to a human. The human can assess the situation through the eyes of the robot, solve the issue, and then move on. In 5 years, I expect when you go to Heathrow Airport, you'll see androids doing many tasks. In 10 years, I think it would also be in elder care, so elderly people living at home will have robots helping them at home, or androids. And then the step beyond that, which is the robots in every consumer's home, I don't want to put a date to that, but that will come later, I think.
I will just, I'll go back in. I'll ask Louis if he's got enough camera footage. Louis? Yeah, you think you've got enough? Okay, great.